Next, we're going to look at chapter 2.1 on frequency distributions and their graphs. And I'm calling this part 1. So this lecture here is going to be focused on really just setting up the frequency distribution, which is like a table. And then in the next section, we'll talk about specifically the graphs. So we'll get into how to actually take those tables and then convert them into a histogram. It's typically what we usually do, or other graph options that we can use. So today, again, we're focusing really on the organization and setting up these frequency distributions, or really tables. There are many ways to organize and describe data. And important characteristics to look for when organizing and describing a data set are its center, its variability, or in its shape. So measures of center and shapes of distributions are going to be covered in section 2.3. So we're not quite there yet, but we'll get there. And measures of variability are covered in section 2.4. So when we talk about an example of measure of center, that could be like an average. For variability, we want to see how spread out the data is. So are most of the data points kind of clustered around the center, or are they pretty spread out? For instance, let's say I gave an exam in one of my classes, and I found that the average score was an 80%. Well, if most of my scores were around 80%, like pretty close to it, then I would say it had very little spread, right? It was pretty clustered together. But if my grades were all over the place, maybe I had some students who had a 10 or a 20, and some students who had hundreds and 90s, and some students who had 50s and 80s and 70s, then that spread is much larger, right? So that's what we talk about spread. Is it close to the center, or is the data kind of all over the place? And then our shape. So we're going to use graphs to see what the data looks like. Graphs are a huge tool to help us visualize data and see if there's a pattern there. So we'll talk about shapes as well. When a data set has many entries, it can be difficult to see a pattern. So we really do have to organize it. We need to graph it to help us see patterns, but we also need to organize it into a table or a frequency distribution. So that's what we're going to focus on here, is how do we kind of organize this data. So a frequency distribution is a table, that shows classes or intervals of data entries with a count of the number of entries in each class. The frequency of a class is the number of data entries in that class. Okay, so here's an example of a frequency distribution or a frequency table. These here are called your classes. So let's see, maybe we were looking at tests. I'm going to do test scores. Okay, so let's say, I'm just making this up. So let's say our data was test scores. And there were 30 questions. Okay. So these could be the number of students who had 1 to 5 questions correct, 6 to 10 questions correct, 11 to 15 questions correct, 16 to 20 questions correct, 21 to 25 questions correct, or 26 to 30 questions correct, right? So for instance, if the frequency is 5, that would mean that 5 students had between 1 and 5 questions correct. 8 students had between 6 and 10 questions correct. 6 students had between 11 and 15 questions correct. 8 students between 16 and 20. 5 students between 21 and 25, and 4 students did very well. They had between 26 and 30 questions correct. Okay, just as an example. So these here are your classes. They're your intervals, but the term we use is class. So those are your classes. So I have 1, 2, 3, 4, 5, 6 classes. And the frequency is how many? So how many in each class? Now, some other terminology here. First thing I want you to know that the classes do not overlap. This is really, really important. There is no overlap. So I'm not doing 1 to 5, 5 to 10, 10 to 15, 15 to 20, right? I don't want that overlap at all. If I have overlapping regions, I don't know where to put my data points. So there should be absolutely no overlap. Each class has a lower class limit and an upper class limit. So these values right here are your lower class limits. It's the bottom number of the class. And then these values here are called the upper class limit, okay? or limits. So it's the highest value and then the lowest value in the class. So your upper and lower class limits. The class width is the distance between the lower limits of consecutive classes. Now, the word consecutive means in a row. So you're looking at, let's say, just the lower limits. So your width would be 6 minus 1, which is 5, or 11 minus 6, which is 5, or 16 minus 11, which is 5, or 21 minus 16, which is 5, or 26 minus 21, which is 5. So notice that your class width is always consistent, right? So our classes are not all over the place. They're very organized. They're very systematic, and our width should always be the same. Now you can also find the class width using the upper class limits as well. So if you subtract these, notice 10 minus 5 is 5, 15 minus 10 is 5, 20 minus 15 is 5, and same thing, 25 minus 20 and 30 minus 25 all give us 5. So you can subtract the lower limits or you can subtract the upper limits. It really doesn't matter. Do be careful though. The class width is not 5 minus 1 or 10 minus 6 or 15 minus 11. That would give you 4. That's a very common mistake that students make is they look at the values within a class, but that's not the class width. Class width goes from lower class limit to lower class limit or upper class limit to upper class limit. Okay, so just be careful there. Another definition would be range. So you want to be careful with range. Range is the difference between the maximum and minimum data entries. So it's not the classes. It's not 30 minus 1. It's whatever your actual data points are. So we don't really have every single data point, but I'm going to tell you that the highest data point was 29 and the lowest was 1. So someone scored 29 questions correct and someone scored 1 question correct. Those were the two extremes. So the range is 28. So your data points have a range of 28 values. Now, how do we construct this frequency distribution from a data set, right? Because theoretically, we usually have the data first, and then we're constructing the table, although we can read the table to get a general idea of what's happening. So the first thing you're going to do is you're going to decide on the number of classes to include in the frequency distribution. So you have some choice as a researcher. How many classes do you want to have? And usually that should be based on the data. Usually it's between 5 and 20 classes. So you want no fewer than 5, but no more than 20 classes. It's like here we have 6. Otherwise, it may be difficult to detect patterns. How do you find the class width? So what you can do is the following to help you get a ballpark of what your class width should be. You find the range of the data, and then divide that range by the number of classes that you want. And then you would round up to the next convenient number. And that will kind of tell you your class width. So in this case, if I just look at it, let's say my range was 28 and I knew I wanted 6 classes. Well, this doesn't come out even, right? 28 divided by 6, that goes in 4 times evenly to give me 4, and then I have 4 left over. So this is 4 2/3. So what I can do is just round up, and I can then use a class width of 5. And you can see that's what I used here for my class width. Okay, so it's a ballpark, it's a rough estimate. So you take your range, so look at all of your data points, see how spread out it is, and divide that by the number of classes that you want to use. Oftentimes you're going to get a fraction or a decimal, so you can round up to the next higher width. If you get a whole number here, a lot of times people will still round up 1. So if this came out to be like 4 exactly, a lot of times people will use 5 instead. It just gives a better breakdown. But there is a little trial and error. So if you try 5 and you're like, oh, I don't really like how that works out, then you can always switch it up, try 4, try 6 instead. After you've done that, you're going to find the class limits. So usually we tend to use the minimum data entry as the lower limit of the first class. That's most often going to be the case in our examples, but you don't have to. So for instance, let's say your smallest value for something was 11. A lot of people would start at 10 instead, right? So you could just use a convenient number instead, but you don't have to. And then you're going to find the remaining lower limits by using that class width. So you're going to keep adding up to get your other lower limits, and then go back and find the upper limits. Remember, classes cannot overlap, so that's going to help you figure out what your upper limits should be. Once you have those classes or those intervals, now you're going to start figuring out how many data points you have in each class. So we can use a tally system to figure out how many are in each class and then count the tallies at the end. So let's do this with an example. I don't think it's not as bad as it sounds. So here's my data. The data set lists the out-of-pocket prescription medicine expenses in dollars for 30 US adults in a recent year. So this is how much people are spending on their prescriptions. We're going to construct a frequency distribution that has 7 classes. So here they're going to tell us how many classes they want us to use. Now, you don't have to, but it does help to put things in order. So if you want to take a minute and just kind of reorganize this from smallest to largest, you can do that. It'll just make everything else quicker, but you don't have to. But I do need to figure out my range first, so I can help start to figure out all those class intervals. So I know I want to have 7 classes, but I don't know what my class width is yet. So I do need to find that range. So I need to find my max value and my minimum value so I can subtract them. All right, so I'm just going to kind of look through here. I see a 155. So far, that looks to be the smallest. 168, 195. So it looks like 155 is my smallest value in this case. And then I need my maximum value. So I see lots of 200s. I see a 300 here. I see a 400. And if I keep going through 400, it looks like it's my maximum. So my range is going to be 400 minus 155. Oh, sorry, 4. Oh, I missed it. There it is. Sorry, 405. I think there's one bigger. 405 minus 155. So again, there's my max, and then there's my min. And what I get when I subtract is 250. So my data is spread out over 250 values. Okay, so 450 is my max, 155 is my min. Be careful. I did it too. I saw the 400 first, but then I kind of looked and I was like, I've done this before, so I thought there was a higher number and it was 405. So just be careful. Again, it may always be easier just to kind of take a few minutes and put them in order as well. So once I have my range, I'm going to find my class width. So I take my range and I divide it by the number of classes that I want. So my range here is 250, and my number of classes, we're told to use 7. Bring my calculator up here. Okay. So I'm just going to go ahead and type that 250 divided by 7 into my calculator, and I get about 35.71. Sunlight's in my way. So there we go. So about 35.71. So I'm not going to use 35.71. You can use decimals if you want in your class widths, but I wouldn't make it overly complicated. Usually when we do decimals, we do like halves or maybe quarters, but nothing confusing like 0.71. So I'm going to go ahead and round that up instead, and I'm going to use a class width of 36. So that looks good. And again, you can tweak this. So you could always try rounding up a little more, maybe using 40 or something a little bit more easy to calculate, but we'll use 36 here. All right, so now I'm going to go ahead and start making my table. So I have my classes. I have my tally next, and then I'll go ahead and add up my frequencies. We just use F for frequency. All right, now you don't have to start with the minimum, but a lot of times we do. So my minimum value is 155. So I'm going to make that my first lower limit. And before I do anything else, I'm actually going to find all of my lower limits. And I'm using that 36 here. Okay. So I'm going to be using that 36. So I'm going to start with that 155. And I'm just going to add 36 to it. Okay. So when I do that, it's a little hard to see on the screen, I get 191. And then I'm going to add 36 to that. And I get 227. I'm going to add 36 again. I get 263. Add 36. Get 299. I get 335. And I need 1, 2, 3, 4, 5, 6. I need one more. I need 7 classes. So I have 371. Now, to find my upper limits, I'm going to just take one less than my lower limit because I don't want any overlap, but I want to be as close as possible. So I'm going to use 190 here. Then for 227, I'm going to use 226. Here it's 263, so the next one down is 262. Here I see 299, so I'll use 298. Then I see 335, so I'll use 334. Let me move this up. My last one is 371, so I'm going to use 370. Now, to find my last piece here, I do need to find my last upper limit. Look at the pattern. Our class width is 36, so the class width is consistent here, but it's also consistent here. So if I'm not sure my last value, I can take that 370, add 36 again, because that's my class width, and I get a value of 406. Now, give it a check. Make sure all your points are contained. My highest value was 405, so that does fit into this last category, and my lowest value was 155. Everything else should be in between, so it looks good. You just want to be careful. Sometimes students who are new to classes, if they're not being careful about their class width, they may not have enough classes, so you may need to go higher. So make sure your highest data point is included somewhere in these intervals. But you also don't want extras. So we don't mind 0 values in the middle, but we don't want our first classes or our last classes to have 0 as a tally, right? So every class on the end should be utilized. So if you're getting zeros, go back, look at your class width. Maybe it was too big, or maybe you have too many classes, or it's too small. So go back and check. But your starting and your ending classes should never be 0. So they should have something in them, and all points should be accounted for. So now I'm going to go through my data points. And again, this is tedious. There's no real shortcut here. And I'm just going to go through and count up how many are in each class. So I'm just going to go in order. So I'm going to do this 200 first and just see where it lies and put a tally mark. So for 200, 200 would be between 191 and 226. So I put a tally mark there. And I personally like to cross it out just so I know I've used it. 239 is between 227 and 262. 155 is in the first class. 252 would be right here between 227 and 262. 384, I'm going to have to scroll down. That's going to be down here in my final class. 165, let me just actually back out a little bit here. Okay, 165, so let's see, 165 is in the first group. Next is 296, which is in this group. 405 is in my last group. 303, let's see, is right here in the middle. 400 is in my last group, and so on. So I'm going to keep doing the last 2 rows. And this is something where if you want to pause the video right now, go ahead and pause it and see if you can do this on your own, right? And get those tallies. All right, so I'm actually going to pause the video myself, and then I'm going to get to the final result. Okay, so I just paused and went through the last 2 rows and put my tally marks in, so to save some time for you watching me do all that. And I just went through and put a tally mark for each one. Now, when you're making tally marks, an easy way to do it is once you hit 5, usually we make 4 lines, and in the 5th line we put a dash through it. Just kind of makes it easy to count in groups of 5. So here I have 3, here I have 2, here I have a group of 5, here I have 5 plus 1 is 6, 5 plus 2 is 7, there I have 4 tally marks and 3 tally marks. So this is my frequency table. Now you do want to check. You want to make sure that your sum is equal to how many data points you should have. Now remember, we had 30 data points here. So when I add these all up, I do want to make sure I get 30, and you do. So 30. Now, some notation here. This symbol means sum. So you're going to see this a lot in stats. So if we write sum of F, it means the sum of all the frequencies. So you do get 30, which checks out. So you want to make sure you have all your values there. Now, technically in our frequency table, if you were doing like a final result or a project, you don't really need the tally in there. You should show it for your work. But if I was going to submit a presentation, I would just have my classes in my frequency like I did in my previous example. Again, I noted that in general, classes should never overlap and the class width should be the same for each class. However, it is possible sometimes for just the final class to be open-ended. For instance, let's say our classes were ages. We could do classes as 0 to 9, 10 to 19 years old, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, and then perhaps we just say 80 and older. So here you have an exception where your last class, instead of breaking it down further, particularly if we don't have a lot in that last group, we can just say 80 and older. So that is the one exception you may see where your class width changes at the very end. But again, it's a rare exception and that should be the only real case, typically with that final class, or maybe the first class as well. If it was doing ages, maybe you could say like under 18, 18 to 30, 30 to, I don't know, 45, something like that. So on those first or ending classes, there could be an exception. But again, it shouldn't really happen too much. For homework questions, if you're doing them yourself, I would not do it unless it was asked to do that. Otherwise, you should have nice classes that end and start.